Okay, so we're going to end off with two topics, refinancing and sinking funds. Um, so, um, right after this, we're going to get into bonds next week, which are, in some sense, a very special case of loans. But anyway, yeah, I'm sure many of you have heard of refinancing a loan. Maybe some of you actually have refinanced mortgages before. Um, okay, so what's refinancing a loan? All it means is we're taking out another loan to fully pay off your original loan at some time. And why would you ever want to do that? Well, because interest rates fluctuate. So in particular, right now, interest rates are really low. Um, I'll explain why interest rates are low right now. As we get later into the course, as we get towards the end, when we talk about yield curves and things like that. But yeah, so they're much lower than they were. They're lower than there were maybe 2 or 3 years ago. So if you took out a mortgage 3 years ago, now might be a good time to refinance, to take out a low interest rate loan to pay off your original loan and just worry about this new loan. Okay. So I want to mention, besides being very, very practical, refinancing, it's also, in the homework, and it could very well be on an exam or quiz, so it's important. All right, so let's say we have a $300,000 30-year loan. Nominal interest compounded monthly is 6%, and payments are at the end of each month. Let's say at the end of the 10th year, you refinance the loan. Interest is 3% nominal monthly. Find your outstanding balance after the 20th year and do the same thing if you don't refinance. Let's compare the values. And yeah, and also I could very well on a quiz or exam ask you a very practical question of, what's the difference between the payments you're going to be making with this original loan and the payments when you refinance, your monthly payments? That's probably the most practical question with regarding to refinancing. And it turns out in this problem, we basically have to answer that to even get the outstanding balance. So, okay, so let's do that. Okay. So let's say K is the monthly payments for my original loan. Okay. Per month interest is 0.06 over 12. Monthly nominal interest is 0.06. So that's 0.005. So as usual, we have a $300,000 loan. Payments are K. We're going to figure that out. We have 360 monthly payment periods if it's a 30-year loan, 30 times 12. Effective interest 0.005. So yeah, we get K is $17.98 and 65 cents. So as usual, 300,000 present value, 360, and always take your decimal times 100, enter as a percentage, and we compute payment, $17.98.65. Okay, so let's put our calculators aside. All right, so this is a perfect example. Well, actually, before I get any further, let's just answer the question for not refinancing. That's the, we have everything we need to do that, so let's just do that. So if I do not refinance after 10 years, the outstanding balance after 20 years is going to be, well, 20 times 12 is 240. It's a 360-month loan, so I can just plug into my formula for outstanding balance of a loan if I have constant payments, which I do. And this is the formula. So let's clear TBM. So yeah, we enter 98.65 negative payments. 360 minus 240 is 120. And again, interest is 0.5%. So we compute the present value. And we get 162,101.62 after rounding. All right. So that takes care of that bit of the problem. This is how much I owe after 20 years if I do not refinance. Okay, so if I do refinance, well, we got to figure out how much I owe after 10 years. That's how much I'm going to pay, or that's how much I need to pay off my original loan, whatever the outstanding balance is after 10 years. That's how much money I need. Okay, so yeah, let's figure that out. Basically, same formula, except instead of T is 240, so T is 240 here, 360 minus 240, 240. Here it's 120, 360 minus 120. So yeah, 1798.65 negative payment, 240, and 0.5 interest. And we get 241,056 and 96 cents. Okay, so this is how much I need to take out in order to rid myself of my old loan after 10 years. And I should mention, this is assuming no prepayment penalty. There usually isn't any, but we'll do an example where there is. So what we're going to do is we're going to reset the loan. Okay, so this is, so I need, and we're literally, not like we're treating this as a reset, we're literally resetting the loan. We're saying I'm now going to take out a 20-year, $251,056.96 loan to pay off, my original loan. Okay, so the new interest rate for my new loan is nominal monthly interest is 0.03 divided by 12, 0.0025. Okay, and it's a 20-year loan. This is how much I need to get right now to pay off my loan, original loan after 10 years. Let's say K is the new payments for this new loan. Okay, so let's figure out what that is. Sorry. So, all right, we basically have this here already. So, clear TPM. So this is present value, 251,056.96, just in round. 240 and 0.25 interest. Compute payments. 1392 and 36 cents. Okay. So for 20 years, for 240 months of mortgage payments, that's a big difference. This is not chump change. This is a difference of over about $400 a month. Our original loan payments were $1,798.65. Our new loan payments are $1,392.36. So that's a big difference. Okay, so what are we going to do? So we want the outstanding balance after 20 years. What this really means is that we're taking the outstanding balance of this new 20-year loan after 10 years. Because remember, after the first 10 years, we got rid of our old loan in favor of this new lower interest rate loan, and now we're looking 10 years into this new 20-year loan. So for this new 20-year loan, N is 240, T is 120, because again, we're looking 10 years into this new loan. So plug into our formula, 240 minus 120. So, well, anyway, so if you dump it into the calculator, you'll get 144, 195, 24. So not only are your monthly mortgage payments not only are they much lower, they're lower by $400. You even owe less after 20 full years. So with refinancing after 20 years, you owe 144, 195, 24, versus if you didn't refinance, 162, $10.62. Okay, so definitely good idea if you can refinance. Okay. All right, so this is basically 3.2.9 in the book, which I will assign next week. So same situation, $300,000, 30-year loan, I-12 is 6%, refinance at 3%. But sometimes it does happen that there is a prepayment penalty. Why would there ever be a prepayment penalty? Well, the mortgage company might want your interest payments. You know, they're making money off of your interest payments. So they might, they might want those interest payments. Okay. I mean, a lot of times they don't, they're happy to take 10 years of interest and then get your money back so that they have more cash on hand. But sometimes, they instill a penalty so that they, to discourage you from paying early. So let's say there's a penalty of P% of your outstanding balance after 10 years when you want to refinance. So a very practical question, and it has a somewhat surprising answer that it's going to be very large. What's the largest P where it makes sense to refinance? Okay. So what we're going to do is we're going to basically refinance the loan, but at a loan payment per month of the original loan, and see what penalty that corresponds to. Because what that means is if we have a smaller penalty and we refinance, then our obviously our monthly payments after refinancing are going to be less. So let's do that. And this is not a hard problem. It's just, we have to think a little bit. Okay. So, right, what did we get in this last example? Well, for the original loan, we got after 10 years, the loan value is $251.56 and 96 cents. So that's how much we need without the penalty to pay off our original loan in 10 years. But the penalty is P% of the outstanding balance after 10 years. So if P is a decimal, it's going to be this outstanding balance times P. So we're going to need, in total, to pay off the loan, $251.56 and 96 cents times 1 plus P. Okay. So as I said, we're going to use for our refinanced loan the original loan payments, and we're going to see what we get for P. Okay. So our mortgage payments per month is going to be the original value, $1,798.65. Okay. So right, but still, like before, this new loan, it's a 20-year loan, so 240 months of payment. It's still 3% nominal monthly, so 0.03 over 12 is 0.0025. And you dump this into the calculator, you get 324, 316, and 23 cents. And if you solve for P, you get P can be as large as 29.18% of your original outstanding balance at the end of 10 years. And it still makes sense to refinance. I mean, I guess literally it doesn't make sense because you're going to have the same mortgage payments and it's probably a hassle. So let's do like a sanity check and just make sure that this makes sense. So in particular, let's take something smaller than this penalty, but still large. Let's say P is 29%. So if P is just barely smaller, then intuitively we should get a mortgage payment for our refinanced loan that's just barely smaller than the original monthly payments for the loan. And that's exactly what happens. Let's see. Okay, so we're basically doing the previous problem, but instead of needing 251.56 and 96 cents at the end of 10 years to pay off my original loan, with the penalty I need 323,863.48. So it's just, just like before, it's 1 plus P times your original outstanding balance at the end of 10 years. Okay. So, right. So to pay this off, to pay off a 20-year loan of 323,863 and 48 cents with payments per month K. Well, it's just, this is the present value as usual of the 20-year 240 month 0.0025 effective monthly interest rate loan. So we just, as usual, solve for the payments, and we get $17.96 and 14 cents. Again, that makes perfect sense. The payment, the penalty rather, is just a tiny bit smaller than the kind of the critical penalty, if you will. The penalty where it just it just makes sense to refinance, or it doesn't really matter if you refinance or not. So we go a tiny bit lower than that critical penalty. It makes sense that we're getting monthly payments that are a tiny bit lower, and in fact they're really a tiny bit lower. They're $2. About $2 less. 17.96 and 14 versus 17.98 13. Okay, so yeah, that takes care of refinancing. Okay, so let's talk about sinking funds. It's a bizarre name. I'm not sure why it's called sinking, because there's nothing really sinking in any way, shape, or form in a sinking fund. It's not like you're throwing quicksand into a fund or something, put something in the quicksand. But anyway, yeah, it's a corporate strategy for loan repayments and for bonds and stuff like that. It's maybe not a good idea to do it as an individual because it's pretty damn risky. But anyway, I'll maybe talk a little bit about that at the end of the lecture video. So what's the sinking fund method to pay off a loan? So you pay off interest each period, and you don't worry about principal. So each period, your principal just stays at L, if L is the loan amount. Let's say little JL is the loan interest rate per period, the effective loan interest rate per period. Okay, so you're going to just pay the full principal off at the end of n periods, which is a bit weird, so what you do, which makes a lot more sense, is instead of making periodic payments for the loan, you essentially make periodic payments, quote unquote, into a fund that will pay off the loan. So what do I mean by that? You make periodic deposits at the end of each month of, let's say, P, big P. You deposit big P, this amount at the end of each period, into an investment earning presumably a higher interest rate than the the loan interest rate. And then after n periods, all these deposits accumulate. It's the accumulated value of an annuity, and then you take that out and use that to pay off the principal. Okay? So all you're doing each period, you're doing two things each period. One, you're paying off interest each period, L times JL. JL is, again, the per period interest rate for the loan. And second, you're making deposits of P each period into this investment, and then at the very end, paying off your principal. Okay. And so these deposits we're going to treat as loan payments. And when you treat any kind of deposits or any kind of payments as loan payments, and we'll talk about this with respect to bonds, it's very important because if you're a corporation, when you file your taxes as a corporation, you have to treat bond interest payments as loan payments. We'll get into that next week or maybe 2 weeks. But anyway, whenever you treat deposits as payments or any kind of, whenever you treat deposits as loan payments or any kind of payments as loan payments, it's called, you say these payments are amortized or the deposits are amortized. So again, we'll get into more into that when we talk about bonds. Okay, so what I want to figure out, and this is easy, but let's still do it. I want the total amount that I'm paying per period. So remember, I'm essentially paying two different values. I'm paying interest and P into my sinking fund, into my investment. So I should say the investment itself is called the sinking fund. Okay? And I guess at the very end, the fund sinks completely to pay off the loan. Maybe that's why it's called sinking fund. But anyway. Okay, so so let's just go back for a second. So what am I doing here? Again, I explained it, but I'll explain it one more time. All I'm doing is I need L at the end of n periods. I make deposits of P into an account at the end of each period at this interest rate to get L at the end of n periods. So all that means is L has to be PSN with respect to this interest rate. This is just a plain vanilla annuity. I need L at the end of n periods. To get L at the end of n periods, I'm depositing P in this fund at the end of each period at this JI interest rate. And of course, capital I represents interest here. I say little JL for the loan. J big I is, the big I is for investment. So this is my investment interest rate, JI, whereas JL, the big L, is for loan. That's my loan interest rate. Okay, so just divide by SNJI to get the amount I have to deposit each period into this sinking fund to have L at the end of n periods. Okay, and that's going to take care of my principal at the end of n periods, but I still have to pay interest per period. And so let me maybe go through this a little bit if it's not clear. So what I'm doing is at the end of the first period, I've accrued L times JL interest. I pay that off. At the end of the second period, I haven't touched principal, so it's still L at the end of the first period. L accrues one period of interest at JL rate. I pay that off at the end of the second period, so I haven't touched principal. It's still L. Do that for the third period. I pay L times JL interest. haven't touched principal, it's still L, et cetera, et cetera, et cetera. Okay. So per period, I have to pay L times JL. I have to make this deposit per period in order to get L at the end of n periods. Well, that's all I need for the loan. I'm taking care of principal at the end of n periods, and I'm taking care of interest every period. So this is my total per period payment. So plug in for P, factor out an L, and we get our formula for the total per period payment. Okay, so let's do the example in the book, and it's a good example. It's a very simple one, but so we have a $100,000 loan. It's to be repaid by 10 annual payments. So the lender requires an interest rate of 10%, and we're paying. The lender wants you to pay this off via the sinking fund method. So you would pay principal in one lump sum at the end of 10 years, and you make constant payments into the sinking fund, earning 8%. And you just do this to pay off principal. Okay. Okay, so find the total annual outlay. That just literally means that's just the total amount of the total you're paying for interest and the sinking fund deposits per year. The total I just had a moment ago, and compare this to the regular way of paying off this loan in 10 constant payments at the end of each period. That's what it means by compare this to the level annual payment required by the amortization method. It just means the usual way of paying off the loan with constant payments. Additionally, find the annual effective interest rate I prime, for which paying this loan off by the usual way that we usually do results in the same total per year payment as we would pay if we did the sinking fund method. Okay. Right, so this is fairly plug and chug. So for my sinking fund, the loan amount is $100,000, 10 periods. The loan interest rate is 10%, so that's 0.1. And the fund's interest rate is 8%, so that's 0.08. So again, remember, big I is for investment. That's the investment fund we're depositing into, and this is the loan. This is the loan interest rate. So it may not make much sense to do this if you get a worse interest rate for your investment, but it's just an academic example. Yeah, so it's just plug and chug. Really not a whole lot to this. So yeah, let's get this here. So it's 1 for the payment, -1 for the payment, 10N, 8% interest, compute future value, take 1 over it, plus 0.1 times 100,000. And we get our answer, $16,902.95. So let's do this the regular way. So here, just per year interest is 10%, so 0.1, and is 10. That was 100,000. So it's 100. It's we're making level payments of something. So we just set this up like we have done dozens of times. So let's figure that out. 100,000 present value, 10N, 10 interest. Okay, I'm not sure what I did, but that's all right. These little things happen from time to time. So this is present value, 10N, 10 interest. So we get a similar answer, 274.54. So yeah, so as you would expect, because we're getting a worse return in our investment fund. Yeah, so it's not really worth it to do this sinking fund. Not really good. It's really not good for us. I mean, the lender might demand it, so we might be screwed. But yeah, but doing it the regular way would give us a less yearly payment. Okay, so right. So let's say we paid off the loan with the same yearly payments as the sinking fund method would require us, 16,902.95, but we're still paying it off the normal way via 10 level payments where the payments are the payments for the sinking fund method, 16,902.95. So let's figure out what the interest rate is. And as always with these kind of problems, you have to use a calculator. So 100,000, present value, 16,902.95. And remember, you have to put minus for the present value or minus for the payments, one or the other, or you will make your calculator upset. And you do not want to do that in the middle of your actuary exam. Okay, and it's going to take a minute to, well, actually, on the calculator, it does take about a second, maybe a second and a half to calculate this, but I guess this is using my computer to compute this, so it does this pretty quickly. And we get the book's answer, 0.1089 or 10.89%. So yeah, that would be the kind of normal interest rate that these payments correspond to. Okay. All right. Yeah, so oops. Okay, so let's talk about outstanding balance. And I'll mention what the outstanding balance means, okay? But as we said before, L over SNJI is what we're depositing each period into this sinking fund. So as I said in general, and this is a useful way of thinking about loans in general when things get a little complicated. So the outstanding balance at the end of T periods rather, is the loan value minus the value of payments. And in this setting, we know what the loan value is at the end of each period. It's just L. We're always paying off interest, and we're always paying off interest. So we even though I do theoretically owe L at the end of each period, I'm not really going to consider that my outstanding balance because I'm making payments into this fund. So my outstanding balance in this context is how much I need additionally to pay off this full loan. If I wanted to just get rid of everything in my sinking fund, I would need that plus how much to pay off the loan, and that's what the outstanding balance is. Okay, so we know what the value of all these deposits are into the sinking fund. Well, it's this, whatever this is, it's this per period, and all this is, it's an annuity that lasts for T periods. So this is the payment per period. This is how many payments we make. It's just a plain accumulated value formula. So this amount, this value, is how much I will need additionally to pay off the loan completely after T periods. Okay, and that's really practically what the outstanding balance means. That's always what it's meant. It meant that if I want to pay off a loan after T periods, I need this much, taking into account everything I've paid into the loan. And that's exactly what we're doing. We're thinking of these periodic payments as paying into the loan. Okay. And so if we do this, we get the formula that the book has. It's a very nice, clean formula. So, and this is really plug and chug. There's not a whole lot to this. Right. So let's look at the problem we had a second ago, and let's just figure out what the outstanding balance is at the end of the 7 years. Okay. Right. So 1 second. Right. So yeah, L is 100,000. T is 7. We're trying to find the outstanding balance after 7 years. 8% is the sinking fund, the investment interest rate, and is 10. So we dump this into the calculator, and we get 38,406.34. So, right, and I've done the storage keys before. Let me just go over how to do it. So yeah, let's say we want to get this one here. So 7N, 8% interest, 1 negative payment, compute future value. So let's store this in the 1 key, store it in any key 0 through 9 you want. Let's do the same thing for denominator, 10N, 8% interest, 1 negative payment. Let's store that in the 2 column, the 2 register. So we want this here over this here. Okay, make that negative plus 1 times 100,000. Sorry about that. And lo and behold, we get our answer, 38,406.34. So yeah. Okay, and in the next video, I will probably do 1 or 2 more examples similar to homework I'll assign next week, and we will start bonds. So yeah, so we're gonna do, let's see. So for the rest of the course, if you're curious, we're going to talk about bonds. And then we're going to talk about measuring the rate of return of investment. This is going to be actually chapter 5. It's going to be stuff that's actually fairly simple compared to what we've been doing. And it's stuff you've probably seen, many of you, before: net present value, internal rate of return, things like that. And then chapter 6, we'll talk a little bit more about kind of interest rates, how they fluctuate, yield curves, et cetera, et cetera. And probably we'll finish off midway through chapter 6. So, all right, as usual, so long, stay safe, keep calm, carry on, and do a lot of homework and do well on quizzes and exams so that you make me happy and make my grading easier and you make yourself happy. So take care.